All right, so, and the region that's common to both of them is this little part right here. Okay, so I'm going to have to integrate the green graph from the pole to that point of intersection. So how can I verify the angle measure of when that green graph hits the pole? Right, where the green graph equals 0 or where sine theta equals 0, which is at 0. So from 0 to pi over 6. The green graph, if I trace the region right there, it goes from the pole to that point of intersection. And so I'm verifying that, or I want to find where the green graph hits the pole. And so anytime the graph hits the pole is where r equals 0. All right, my green graph was sine theta. Okay, and then when I switch over to the purple graph, I'm going to integrate from pi over 6, that point of intersection, to where? Pi over 2, right. And I know it's pi over 2 because this, on the purple graph, this is where theta equals 0. And then it's where it hits pi over 2 is right there. And that just gives me half of what I'm really looking for, so I have to multiply the whole thing times 2. And it's a very strange answer, 7 pi over 12 minus root 3. The calculator spits that out when you type it in. Just to kind of help you visualize a different way of doing this, if I wanted to just kind of go through the whole part of that, then I could have gone from 0 to pi over 6 of the green graph, obviously squared, because that's the formula. And then for the purple graph, I would have gone from pi over 6 to pi over 2, but I would have kept going all the way until I get the second point of intersection, which is 5 pi over 6. Purple graph squared. And then I would have to go back on this other little part of the green graph, which would be from 5 pi over 6 to where, do you think? Pi. Very good. Because here was pi over 2, and so if it's just going through there, it's going to just hit at pi. Now, you can always verify that by tracing on your calculator.